So we'll continue learning about polynomials in these videos for the second lesson about this 7-1. So first, let's understand what the standard form of the polynomial is. So we have a polynomial here, and we've got 1, 2, 3, 4, 5 terms. Each term has a sign. The first one is positive, the second one is negative, third one is negative, positive, and then the last one is negative. So we are going to rearrange them, but we are going to put the term with the greatest degree first. So here we can see that the greatest exponent is 4. So this will be our first term. So 6x to the fourth. So we start by writing that term first. So the next one we notice is 3. So that's why we write this guy right here, over here. So writing them in what is called descending order. Please remember, descending order means going down. So we are, this word right here, descending order. That means that our exponents are going down. Okay, so starting with the greatest degree, you're gonna write all the terms without changing their sign. That is also very important. So right here, the terms that were positive are still positive. The terms that were negative are still negative. So do not change the signs. So that's on the one hand. So now I'm gonna ask you please to pause the video and see if you can rearrange these polynomials in standard form. Okay, and after a while, I hope you paused it. I want you guys to check all this work. I want you guys to do it in your notebooks. So the right answer is negative 3x to the third power plus 6x to the second power plus 7. And if you were to do the same thing with the other one, hopefully you had a chance to pause the video. That will be the correct answer. Okay, so now let's go to example 3. So for example 3, we're gonna watch a very interesting and cool video about this. All you have to remember here is that when you want to calculate the area of a rectangle, sorry about my rectangle, but you always, like, say that you're thinking, oh, these are squares, and if they ask you to calculate the area of this rectangle, so this is going to be like 1, 2, 3, 4. So they are asking you how many little squares you have in this rectangle, and you have 4 for the length and you have 2 for the width. So to calculate very quickly how many of those squares, little squares you have, instead of counting each one by one, you can just multiply it 4 times 2. So 4 times 2 will give you what is called the area. Okay, the area of the rectangle. So you multiply the length times the width. So please keep that in mind as you watch the video, which is very, very cool. All right, so we'll play the video.
How can you use the properties of operations to combine like terms and write the expression 4x plus 3x squared plus 2x plus x squared plus 5 in standard form?
So
you can use algebra tiles to model the expression. This tile has side lengths x by x, so it represents an area of x squared. This tile is x by 1, so its area is x. This tile is 1 by 1, so its area is 1. To model this expression, you can model each term one at a time. 4x needs 4x tiles. 3x squared needs 3x squared tiles. Then you need 2 more x tiles, 1 more x squared tile, and 5 ones tiles. Like terms have the same variables to the same exponents.
So notice that here, when we are writing a polynomial like this, it's like you're adding or putting together objects of 3 different sizes. So there is this size in green, there is this size in blue, and there is this size in purple. So of course you cannot combine them all because they are not all the same size. You only combine the ones with the same size.
Algebra tiles, these terms are terms modeled using the same tile. So, for example, you can combine x squared terms, but you cannot combine the x and x squared terms. Rearrange the tiles to group like terms together. There is a total of 4x squared tiles, or 4x squared. There is a total of 6x tiles, or 6x. There is a total of 5 1 tiles, or 5. The expression 4x plus 3x squared plus 2x plus x squared plus 5, written in standard form, is 4x squared plus 6x plus 5. You can also rewrite the expression in standard form.
Now please notice how you can do it without the algebra tiles. So these are called algebra tiles, but now we are not using algebra tiles.
Form using the properties of operations. Identify the like terms. Then rearrange the terms in the expression to group like terms together. Then combine the like terms. The expression in standard form is 4x squared plus 6x plus 5.
All right, so with that in mind, please see if you can combine like terms in the following 2 exercises. As always, pause the video, and after a while, please check your answer. So after you combine, you actually end up with only 3x to the second power. Notice that here there are 2 terms that form what is called a zero pair, because negative 3x plus 3x simplifies to 0. So it's a pair that simplifies to 0, so it's called a zero pair. And for this one right here, you got the answer that you see there. Please write it in your notebook, problem and answer, and see if you can see the connection there. I will stop this first video there. I need you guys to start practicing, please. So